So it got very messy. They ended up finding a community who believes maybe there really is something to cold fusion, and that when they can prove it, they're just going to make $1 jillion, right? So there's people backing them. And last I heard, Hans lives in the south of France, where he has a nice, well-funded lab. I don't think they're doing anything. There they are. Maybe I'm wrong. Maybe they're right. But it was fascinating to watch. How does science decide anything is right? It's sort of what you're watching happen with these things. Go on. Mm-hmm.
I just have a quick question to just seek some insight. I was just wondering what you guys were involved in during your undergrad years, and how did you get to where you are today?
So I was very lucky. So I went to undergrad at Virginia Commonwealth University in Richmond, Virginia, and they have a very good honors program. And so I was involved with the honors program, and I was able to take some short courses and some modules, and that were really, especially the science modules. There was one that was intensive on like classic papers in the sciences, and another that was about great scientists of the past, and also through the honors program, I was able to take a course where I would write my own sort of mini grant proposal, and then actually in consultation with a faculty member, and then I actually got to go into that faculty member's lab after the course was over and start working on that project. And so I was able to actually get into a lab my junior year, and I ended up working, so basically 2 years in that lab, and ended up with a first author publication. And so that's, I'd already had an inkling that I wanted to go into research, but that really was sort of cemented in my mind that that's what I wanted to do, because it was just so awesome to go into a lab and to be able to ask questions and then design experiments and be able to try and answer those questions. So I think the ability to actually go into the research lab while I was in undergrad was probably the best opportunity that I had.
So I was actually right down the road from you. I was at William & Mary.
All right.
I actually was a physics major, and I was going to study cosmology or nuclear physics or something, and figure out how the universe fundamentally works. And at some point, I decided that there were other really cool questions about how the brain works. And I also worked in a lab. I actually worked on analyzing ultrasound data as a senior in a lab, and got a nice senior project out of it. And decided I was going to try to do an MD PhD. So I went to Cleveland, where I worked in a biomedical engineering laboratory and on developing a neuroprosthesis. So some of the 20/20 kind of things you see, where they have monkeys reaching for things and controlling robot arms and all that kind of stuff. I did nothing anywhere near that fancy or cool. But it was sort of in that ballpark, and it sounds very cool. And I found that I did indeed really like studying the brain and trying to understand how it works. So I quit trying to make stuff and finished med school, came here, did a neurology residency, and found that I really was interested in this subset of neurologic disorders called movement disorders. So these are things like Parkinson's disease and tremors and so forth. And because my background was in physics and engineering, I thought that I might be able to study some of these things and try to understand how the circuit that is malfunctioning in these things might actually work. And fortunately for me, this is about the time that deep brain stimulation, I don't know, you guys know what deep brain stimulation is? So for Parkinson's disease and a few other disorders, there's a therapy now that actually works quite well. They put an electrode deep into the brain, and they turn it on, and it helps Parkinson's symptoms, and it helps tremors, and if...
What's the signal they put into?
It's just a 130 hertz biphasic square wave.
Square wave? Have they tested triangle waves?
Yeah, I mean, they're so part of the reason they're square waves is because they're easy to make.
Sure.
And you've got this little implanted device and this thing going into the head. So one of the things that Medtronic is now coming out with a current controlled one, which is, this is a big deal because all the old ones are voltage controlled and they're not quite as consistent in their stimulation. So no one has any idea how this works, basically.
So what's the difference between medicine and fundamental science? In medicine, if it works,
Right. Well, it's
I'd like to know. You know.
It's very interesting bouncing between the lab and the clinic, because in the clinic, I don't care why it works. All I care is that it works. And in the lab, you don't really care if it works. All you care is if you really understand what's going on, to some extent. So anyway, so I sort of had this entree into what's become a sort of very hot medical field, with trying to understand how deep brain stimulation works and how you might fix it and how you might target different parts of the brain. And so that's sort of where I want to go.
Yeah. So my story's older, but it's sort of the same, right? I came to college. I was a first-generation college student. I didn't know anything about being a scientist or even anything. So I started studying physics because my brother did, right? It's how you make those choices in college. And I got involved in research basically because someone took me by the collar and brought me into a lab. Said you should come work in the lab. And that's how it happened for me. And that was a big important thing. It's not like in the beginning it was super exciting or anything. They made me change the oil on all kinds of pumps and stuff like that. Seemed like a job, but that's how it started. And then you get to the point where you can start to say, wow, they're doing something here, and maybe I could do that too. And so a lot of people helped me along getting started in doing that. And it's when I got to the point that I was doing something that was really different from what you do in class. I mean, I like physics classes. I don't know, you solve problems is kind of fun. You get to the answer, you feel kind of good. But I don't think I would do that all my life. But doing science is nothing like that. It's nothing to do with solving problems in a book. You enter a lab, you don't even know what the question is, much less how to solve the problem. Nobody knows how to solve the problem. That's the whole point, right? So it's a totally different kind of endeavor. When you do your homework, you maybe sit there alone, you do your homework. Science is not like that at all either. Science is always working with other people, and trying to figure out how to get people to bring all their resources to the table and accomplish a project. So it's very interactive with people. I really like that. Very international. It's so cool to work in a field where national borders are like irrelevant. It doesn't matter what country you're from. Nobody cares, right? And there are not many fields where that's true. I mean, even businesses and stuff, yeah, they get multinational, but it's just not science. Everybody shows up at the meeting. You don't even know what people. It doesn't matter where they're from. There's no boundaries.
Yes, it's pretty remarkable going to a meeting and see people from places that should hate each other. I'm serious. I mean, it's not that everyone in science is a great human being. I mean,
lots of these people hate each other, but they hate each other because of scientific concepts.
Right. They hate each other because of interpersonal differences, not because their nations don't like each other or something.
And you do see this right on the surface sometimes, and it's I remember watching a very famous scientist here give a talk, and he said, I'm going to start with a review of the field, and if I don't mention my competitors' results, it's not because I'm not aware of them, it's because I hate them. It was a little bit, but it was funny. So people can be quite, it can be super personal. People really want to discover things first and get it right. They really want to. And in the end, you do or you don't, but they really want to, so they push really hard. So, not always. Many people are just nice about it. It does get tough. Yeah.
To go along with that, what was one of the best pieces of advice you may have heard in terms of your academic goals or your career?
Best piece of advice. I had a wonderful thesis advisor when I was in graduate school. I went to graduate school at the University of Chicago, and I worked with a man who was very famous actually, but he was not like a lot of famous people. He was, sometimes when people get famous, they just kind of ride that for the rest of their career, and they stay in the top of this huge group, and they're very powerful and influential and everything. And he just decided at some point that he wanted to do new things, and so I actually met him when he was starting a wholly new kind of experiment, basically building it himself. He still had influence, so he could make stuff happen, but he really walked away from a lot of stuff, and I like that. But he would say to me a number of times,